Good day. Let's look at chemistry. Particularly, we are on practical chemistry and specifically on volumetric analysis. Today, we are going to look at how to calculate percentage purity or percentage impurity. Now, a sample question is here. And the question is saying is 3.0 gram of an impure sample of sodium trisulcarbonate 4, which is Na2CO3, was dissolved in distilled water and the solution was made up to 250 cm3. If 25.00 cm3 of the solution on titration completely neutralized 20.40 cm3 hydrogen chloride acid containing 0.2 mole of the acid per dm3, you should calculate the percentage purity of the sample of sodium trisulcarbonate 4. So the equation for the reaction, the balance equation there is 2HCl, which balance the acid, and then 1 molecule of sodium trisulcarbonate 4 will produce sodium chloride, the aqueous solution, water, and carbon 4 oxide. Now, to approach this question, we need to understand the principle that in all reaction of neutralization, we should understand that if there is impurity involved, only the pure component will react, but the impurity do not. I repeat, only the pure component during the titration will react, the impurity do not. And they want us to know the percentage impurity that was involved in the reaction that do not actually take part in the reaction. So in this order, there are some quantities that are given to us. If I should rewrite the equation as it is here, of course the equation is here, sodium trisulcarbonate, the mole ratio of acid to base, of course this is sodium trisulcarbonate 4, the base, and then HCl is the acid. This is sodium trisulcarbonate 4, the base, HCl, the acid. So for us to tackle this question quickly, we need to quickly convert the value of 3 grams of impure sodium trisulcarbonate 4 that was dissolved in 250. 250 is not a standard, but we have 1000 cm3 as a standard, and that will make it, assuming the 3 grams was dissolved in 1000, we'll not see 250 here again, and that will give us a standard solution. So dissolving 3 grams in 250 is not a standard solution, except if it is 1000. So we need to convert from 3 grams against 250 to 1000 before we continue. Meanwhile, the volume of the base used from the pipette used in the laboratory, of course this is alternative to practical. Alternative to practical in the sense that I don't need practical on this one. It's just November, December or GCE exam, you can see this kind of question. So you are expected to use the data here and do your calculation, assuming that you're in the laboratory performing this experiment. So you need to understand that this 25.00 cm3 is the volume of the base that was pipetted for this experiment. And after all the titration, it was neutralized by this volume of acid, the acid. And the volume of the acid that neutralized the base, 25 cm3 of the base, was 20.40 cm3. So which means that our VB is 25 and our VA is 20.40. But before then, we need to do this conversion from 3 grams against 250 to 1000. And to do that, you now say 3.0 gram of what? Sodium trisulcarbonate. Then produces 250 cm3, which was all 1000. Then assuming we want to make this solution a standard, we have to ask ourselves how many grams will be dissolved in 1000 to make it a standard solution. Then the simple mathematics is 3 over x is equals to 250 divided by 1000. To get this result, you cross multiply this way, and the value that is attached to what you are making subject of formula will always come down, and that will give us x is equals to, then I'll rule a line like this, and I'll now know that because x is going with 250, 250 will go down. But any value that is not connecting with the variable we are making subject of formula, that is 1003, will go up. That will give us 3 times 1000. And if we do that calculation, if we get that calculation down now, it is going to give us 3 times 1000 divided by 250. Answer is going to give us 12 gram. So the answer I have there for x alone is equals to 12 gram, 12.0 gram. And now I'm going to add per dm cube, meaning that per 1000. Of course, you should know that 1 dm cube is equals to 1000 cm cube. So it was dissolved now in 1000. So this becomes the unit measurement of this value of x. That is 12.0 gram per dm cube. That is the percentage impurity that was involved. And this is called impurity. Sorry, it's called the impurity, not percentage impurity. The impurity that was involved is this one. Now, how do we get the pure component that actually do the reaction during neutralization? We need the pure component, and this pure component we can find it from this relationship CaVa all over Cb Vb is equal to the mole ratio of acid to base. And in this case, the mole ratio, the acid is here, is A, and the base, if there is nothing here, it means 1 mole of sodium trisulfide, which is 1. The acid is 2. Now, we have already been given the values of Ca, which is 0.2 mole. Ca, of course, if you put it here, Ca is equal to 0.2 mole per dm cube. According to the equation, 2 mole per dm cube. 0.2 mole per dm cube. 2 mole per dm cube. And then our Va, which is the volume of the acid that neutralized, is 20.40. Is equals to 20.40 mole per dm cube. Now let's look at the value of Cb. The value of Cb is equals to question mark, and that is the pure component that reacts from B. And then the value of Vb, they use 25.00 cm cube pipette. We only have 20.0 cm cube. Assuming you have 20.0 cm cube, this value can change with time, but what you need to know is that we have 2 sizes of pipette, or even more than 2, but the common one we use is 20 or 25. But for this question, they use 25, so be careful about this location. So it's going to be 25 we are going to use now. So the answer for Vb, in fact, is the pipette you use in laboratory to put in your bag just to suck off base. So it's 25.00 cm cube. That was the pipette that was used for this experiment. So now, in our marking scheme, in YF marking scheme, for you to make Cb subject to the formula here, you get marks. There are marks that are located to it. Then I know to make Cb subject to the formula, anything that is going with Cb will come down. The shortcut Cb will be equals to, if Vb cross multiply like this, which means that we're going to have Vb times A will go down. Then what is up now is anything that does not contain Cb will go up, and that will give us CaVa multiplied by B. Now our value Cb is equal to, our Ca is 0.2, our Va is times what? 24.40. Our B, which is the mole ratio of the base, is 1, divided by our Vb, which is the volume of the base, is 25. But the mole ratio of acid is 2. And this gives us Cb is equals to, Cb there for the value, if you use your calculator very well, which I know is not a problem. So it's going to give us 0.2 multiplied by 24, sorry, this is 20. The value of this is 20, not 24. 20, let me correct that. So we have 20.40 multiplied by 1, then divide the result by 25 times 2. So answer I'm getting there, the result of the answer is 0.08. This value, make sure that this value must be to 3 significant figures. CA and CB in your exam, WAEC exam, whether May, June or GCE or whichever WAEC exam you are writing, any series you are writing, that the value of CA and CB here must be to 3 significant figures. To make it 3 significant figure, the last value I have there is 686. This make it 3 significant figure. But remember the unit, mole per dm cube. So CA and CB, they are in mole per dm cube, and then VA and VB, they are in cm cube or dm cube if you have converted it. So this is the idea. Now this is the value of the pure component of sodium trisulcarbonate 4 that actually react. For us to get the mass that was involved, the mass now uses this formula: molar concentration is equals to mass concentration, and this is always in gram per dm cube all over the molar mass. Either you call it molar mass or you call it formula mass. So now, what is the formula mass of sodium hydroxide? Sodium trisulcarbonate 4. The formula mass of sodium trisulcarbonate 4 is the compound I'm talking about. So for me to get this, and this molar concentration is that of CB, because it's CB that you're looking for. If it is CA you're looking for, this becomes CA. So here is always in gram per dm cube. Now the value of this is what we need. The value of the pure sodium trisulcarbonate 4 that was in gram per dm cube. Doing that, I'll quickly write in this place for us to find NaCO3. First of all, find the molar mass of this to replace this. It's going to give us sodium is 23. Remember, it will be given in the equation, even though I did not give you. These are the relative atomic mass. So 23 multiplied by 2 plus carbon is 12 plus oxygen, which will give us 16 times 3. So the whole value, if we calculate it together, we're going to give us a result, and that would be 23 times 2 plus 12 plus 16 times 3. 16 times 3. Answer will give me 106. So what we have here is 106. But the unit is in gram per mole. It's in gram per mole. That's the unit of molar mass. Now to find this result now, it therefore means that in place of this, I'm going to write 0.0816 is equals to, in place of this, I can put there Y, because that's what I want, the mass I want, divided by, in place of this one, I'm going to put 106. So to conclude the matter now, is going to be by cross multiplication, cross multiply this by 1. So Y will go here and this one will come here. It's going to be Y is equals to 0.0816 multiplied by 106. Our Y will be equals to, multiply that result by 106. What will give us the result there? 106. So if I multiply 106 by 0.0816, answer will give me 8.65 approximately. 8.65. The answer will give me 8.65. And this value, because the unit is in gram per mole, so we put it gram per dm cube. So we have already gotten the mass concentration of sodium trisulcarbonate 4, the pure sodium trisulcarbonate 4 that actually reacted. Now the idea now is to find the percentage purity. Percentage purity have a relationship. Percentage purity is equals to mass concentration of pure component. Alright, component in short, mass concentration of pure component multiply the result by 100 over mass concentration by mass concentration of impure sample. Mass concentration of impure sample. So that is the formula now. So at this point in time, to get the answer now, percentage purity will be equals to, what's the mass concentration of the pure component? This is the mass concentration of the pure component that actually reacted. The mass concentration is 8.6, so I'll now put 8.65 divided by the mass concentration of the impurity of the impure sample. The impure sample that was given, we have converted it to standard, that gave us 12.0 gram. That will give me 12 multiplied it, because of the percentage, multiplied it by 100. So percentage purity will be equal to, using your calculator, you can find the result quickly. Using the calculator, you can find the result quickly, and that will give us 8.65 multiplied by 100, divide the result by 12. If you divide the result by 12, what I have there, the answer is 72.08%. That is 72.08%. That is the value of the pure component that was involved in the reaction. The pure component is that. We equally have some other formula that relate percentage purity. Like we have percentage purity, this one becomes percentage impurity. Percentage impurity will be equals to mass concentration of impure component times 100 all over mass concentration of impurity. Or like if you are asked to calculate the percentage impurity now, you can still use this formula again. This one is formula number 3. This one is supposed to be formula number 1, which we have used to calculate in the question. Then this one is formula number 2. It's talking about impurity. This is a different. This is purity. This is impurity. So we will have that percentage, formula number 3. We will have that percentage purity plus percentage impurity is equals to 100, which means that once you get percentage purity, you can quickly get percentage impurity without even using the second formula. So like this one now, if I want to use example now, the percentage purity I got is 72.08%. So if I put it here, it's going to be 72.08 plus percentage impurity will be equal to 100. So my percentage impurity now will be equals to 100. If you take this one to cross like this, it becomes minus 72.08. So the answer you can get there, that is additional information. already we have ended up calculating our percentage purity from here. Then that will give us 100 minus 72.08. Answer will give me 27.29. 27.29%. That is the impurity that was involved in the sodium triazocarbonate 4. If you like my YouTube channel, subscribe, and then just for the progress of this channel, we are going to be continuing like this on different subjects. So today is chemistry. Some other ones have been done on other subjects like math, physics. So today we are on chemistry practical. I'll continue from here, and next time when I come, we're going to be calculating based on the number of ions in the solution, or can calculate in what we call the amount of ion in solution or number of ions that are found in the solution. Thank you.